Savings accounts are useful for being able to gain interest and essentially make money on the money that you are saving. Interest is based on both the interest rate in which you receive and your principal, aka your balance in your account. There are two classifications for interest, and that's simple interest and compound interest, which you previously learned about in Algebra 2. Simple interest is interest that is based only on the original principal. Therefore, our simple interest formula is really just a linear function in the form of y equals mx. So we still have two variables, and then the only difference is instead of one single parameter, we have two parameters that combine. So our variables in this case would be your interest, which we might denote as y, and your time, which we might denote as x. So those are the two things that are changing. However, once you get things set up, your principal remains the same because you're only depositing one initial amount. And then your annual interest rate, which we express as a decimal, that also stays the same. So these are both constants. We might also call them parameters. So for example, say we have a principal amount of $300, so we're putting $300 into our savings account. And then we have an interest rate of 2%. So since we're multiplying P by R, and we have to express this as a decimal, this would be 300 times 0.02. And then we multiply that by our amount of time, and it's going to tell us how much interest we have earned. So after, for example, 3 years, so if t equals 3, then I would substitute 3 in for t, and calculate that, telling me that my interest after 3 years based on this information would be $18. So notice at an interest rate that low, along with an initial deposit that low, you're not earning that much in interest. But what you can see here, we could simplify this equation even further and take 0.02 times 300, which simplifies to 6. So really what this is saying is that we're earning $6 in interest per year. So if t is 10 years, then 6 times 10 tells us we've earned $60 in interest. But again, that 6 comes from taking the principal multiplied by the annual interest rate. And as you can see how this is an example of a linear function, our rate of change is 6. Technically, our initial value in this case is 0 since you aren't earning any interest when you create the account, but it is growing by $6 per year. Obviously, the higher the principal and the higher the interest rate, then the higher amount of interest you'll earn per year, or the higher the rate of change in this case. In example number 1, Gina wants to deposit $4,000 in a bank for a period of 2 years. She's comparing interest rates quoted by 4 local banks. We want to calculate the amount she would have in her account after 2 years. So we should be able to determine which is the best option just by looking at these interest rates, since she is earning simple interest and the only thing that's changing is the interest rate itself. Her initial amount is still $4,000 and her amount of time is still 4. So for First City Bank, we would take 4,000 times the interest rate of 0.425. Sorry, 0.0425. Very important because she's not earning 42.5%. And then multiplied by 4. So the interest she's earning would be $680. That means the amount in her account after 4 years would be $4,680. For GSave Bank, again, we're doing the same thing, but now our interest rate is 4.375%, multiplied by 4 again, and this gives us an interest amount of $700. So she would have $4,700 after 4 years. Hamilton County Trust, changing that interest rate to 4.22%. And that's a total interest of $675.20. And for Bear Savings Bank, her interest rate is 4.3%, which is $688 in interest. So her total amount is $4,688. So as we said, the one with the highest interest rate is going to give us the highest output. So in this case, the 4.375%. If you accidentally forget, say, a zero in your calculation when you're converting a percentage to a decimal, you should easily be able to tell when you've made a mistake like that. If I had forgotten that zero and just put 0.425% times 4 years, then it would have told me the interest she earned was $6,800, which should not make sense in this case. So that's when I know I need to go back and make sure I didn't make an error. Example number 2, we're asked how much simple interest is earned on $5,000 in 3.5 years at 4.2%. And then how much interest is earned on $3,000 in 7 months at an interest rate of 3%. So for this first one, our initial amount, or our principal, is $5,000. Our interest rate is 4.2%. And our amount of time is 3.5 years, so 3.5. So that is a total amount of $735 in simple interest. For the next one, at $3,000 principal and a rate of 3%, 7 months. So since our time is normally written in years, we have to convert this to a fraction. So we could just say 7/12 since it's not a full year. And if we do that calculation, we get a total simple interest of $52.50. In example 3, this time we are solving for how much principal needs to be deposited to earn $2,000 in interest in 2 years at a rate of 6%. So in this case, we are setting up the equation to be able to solve for P. So since 2,000 is our simple interest, we'd say 2,000 equals P times our rate of 0.06 times 2 years. And if I simplify that, I get 2,000 equals P times 0.012. So I can actually divide by 12%, and that will calculate how much principal I needed to start with to be able to earn $2,000 in 2 years at this interest rate, which in this case would be $16,666.67. And in example 4, we're told that Eric has a bank account that pays 5.1% simple interest. The balance is $810, and we're asked when he will have $1,100. So first things first, that means we have to calculate how much he must earn in interest. So 1,100 minus 810 is a total interest of $290. So this time it's asking us for the amount of time it takes to earn an interest of 290. So we'd say 290 equals, start with 810, multiplied by our interest rate of 5.1%. And then we are solving for the value of t. So once we simplify this, we get 290 equals 4131 times t. So to solve, we divide everything by 4131, and that tells us that the amount of time this is going to take will be approximately 7 years. So at this point, go ahead and work on the application questions number 1 through 4. As I said, on Canvas, I will be in during the afternoon, so if you'd like to meet during block 5, please just send me an email.